we want to design some nice, nifty system like this independent vacuum cleaner robot. But to do that, we have to first develop the system on a development board and develop software on it, of course, application software. So the question is, how do we get our application software on that development board and on the final board? Today, I'm going to talk about distros to get your basic software, a Linux system, of course, on your embedded targets. And I'm going to compare two things here, a Debian-based distro and a buildroot-based distro. My name is Arnout Vandecappelle. I work for Mind, which is on top there, and I'm a consultant, so I get to see a lot of different ways of using embedded systems and ways of putting the software into the embedded system. And that's why I'm able to give this kind of comparison between Debian and buildroot. Now, first of all, we have to realize that embedded systems are a bit special. So I'm first going to talk about what is so different about embedded systems and what impact does that have on the distro. Second, actually, a large part of my talk is going to be about Debian and how to use Debian in an embedded system. And then finally, I will talk about buildroot, and I'm going to advertise a bit about buildroot because that's a project where I'm a contributor. So why are embedded systems different? There are many things why an embedded systems are different, but here I'm going to focus on the things that make it different from the perspective of a distro. One of the most important things is that it has to be controllable. In a normal desktop system, you basically want to be flexible in installing packages and configuring your system. In an embedded system, the developers really want to have control over as much aspects of the system as possible. For instance, they want to be able to fine-tune the configuration of services, which ports are open, how much RAM is consumed by, or what the maximum amount of RAM is for a certain service, whether it has SSL enabled or not, or whether it's only SSL and nothing else, things like that. A second typical aspect is that in an embedded system you want to hack it so that it boots very fast. So throw out things which are not needed and make sure that it boots fast, so that your vacuum cleaner robot, you just press the power button and it starts cleaning right away instead of first booting for 5 minutes. And then also typically you want to customize packages and most importantly the kernel, because once you start developing your own custom board, you often have drivers in there which are not in a standard kernel, or if it's not using device tree yet, you need to have a board support package for your board. So very often you need to make a custom kernel. By the way, I have a cold, so I'm sorry for the coughing all the time. You'll just have to bear with me. A second important aspect is that it needs to be reproducible. When somebody in the field encounters a problem after a year after you've released it, you have to be able to reproduce that problem, and that means that you also have to be able to reproduce the software on which that problem is running. You can, of course, use an existing binary, but that binary is typically stripped and doesn't have debugging symbols, doesn't have the source codes, so you can't really debug with it. So you have to be able to recreate something very near to the actual release product after a fairly long time. And second, you also want to be able to make exact copies. So you don't want to go the way of a typical server environment where there is some chef or puppet that just installs stuff on all the different servers, because that will usually take too much time. When you're mass producing those vacuum cleaner robots, you will have some factory and there is someone there that connects something to the device. it's a fairly untrained worker, so it has to be very simple. And then after you connect it, it should just copy the image and be done with it in as little time as possible. So that's why you typically want to create an image and not just an installer. Even if it's an automatic installer, you don't want to do that. You just want to copy an image to the target. And I'm running out of space here, but hopefully you can still read it. Embedded systems are typically also small. For instance, in our vacuum cleaner robot, we're not going to put a gigabyte of flash. We're going to put maybe 120 megabytes. Somewhat bigger systems have maybe a gigabyte of eMMC, but every additional gigabyte will add to the cost, and embedded systems are usually very cost-driven. And then also very important is that you're very often using non-desktop instruction set architectures. So ARM is the most common one, but you also have many systems using PowerPC, MIPS, and then even more exotic processors like the ARC, the Extensa, the Blackfin, and the Microblaze. And so you have to deal with those foreign processors. So with all this in mind, it sounds like you really want to be doing Linux from scratch. You really want to start from source code and build everything. But if you do that, you're going to spend a lot of time on just getting your basic operating system going, and then you have to still start writing an application, and that's actually the interesting part of the work, writing your application. So starting from scratch is not really the best way to go. You need some infrastructure which helps you in deploying a running system fast. So what does it mean, being able to deploy fast? First of all, you want to have an initial deployment on the on the dev board you get from the processor vendor. You want to have that in no time, in hours or minutes even. So basically, you want to do that in the time it takes to download it and not spend time on configuring it. And then starting from that, you can experiment and add things and improve the system. Second, it has to build fast because the entire building is in the development loop. You very often, although you can do the application development on your PC, very often you want to run it on the target to see how it really behaves. So you have a fairly long development loop there. So to make that as short as possible, it has to build fairly fast. And then, of course, it has to be controllable. So you definitely need to, it has to be easy to change the configuration, to add new software, or to tweak certain parameters. Also important is to be able to share with colleagues. So it has to be, that's part of reproducible. When you configure something, you have to be able to give it to somebody else, and they have to be able to continue with it. If you would start from scratch, then you have maybe a recipe of all the steps that you have to do, and your colleague has to reproduce all that exactly to know where you are. So that's what you want to avoid. And then, as I said before, you want to make an image for production and also for upgrades often to be sure that after an upgrade, you know what is installed on the system. You want to upgrade with the whole, the full image. And so if you have really an image, that makes things easier. And then finally, it has to be easy to add your own software to the system and still have it controlled in this built infrastructure. Now, many of these things sound very much like you need to use a distro. So let's take a distro, for instance, Debian, because that's where I have experience. But actually, most of the things I say go to some extent also for other distros. Typically, the tools which are developed here are also used or usable in other distros. So how do you start your system with using Debian? Well, you start with an installer or minimal tag file, and you play around with it. So that matches the first requirement, being able to go up and running in no time. Usually the live CD doesn't really work unless you have an x86 architecture. But very often there are simply no live CDs for your particular board or architecture. However, most distros, and especially Debian, they have, for ARM at least, and for some others, they have an image which contains a file system or a net installer, and you can just copy this file system to your an SD card, for instance, or something else that you can boot from, and then reuse the bootloader and the kernel that are given by the vendor. When you buy a development board, nowadays almost always Linux is provided with it, and so you get an SD card or some bootable media with a bootloader and a kernel, and you can start from that, and then you can add any kind of root file system to it. So you can just take your Debian root file system, extract it to the SD card, and voila, you have a Debian system. And then, of course, you install it to permanent media, like this SD card. And here you have to be a bit careful, because you will probably make some combination of just installing packages, but also some tweaking of config files, or installing packages which are, well, installing software which is not packaged. So you have to keep very careful track of what you're doing. And then finally, you create an image creator script, and that's the hard part of using Debian. And of course, you once it goes to production, you need to make something that can write the image to the target. So, creating a Debian image. This is the easy way. That's basically when you go to an x86 and your development host is also an x86. You start with building your custom packages that need to be built from source. And there is a tool, pdbuild, that does that almost fully automatically for you. It will make a root environment, download all the build dependencies, so everything that is needed to build that one package, then build your package, and then exit the root environment and give you that package. So that gives you a way to be very sure that it's reproducible, because you basically for every build you start from scratch. So then you have your custom packages, and then the Debian repositories for all the normal binary packages, and then there is a tool, debootstrap, that allows you to make in another root environment a Debian system, a root file system. So you use that, then you root into it and apt-get install the required packages. Then finally, if you have some tweaking to do, you make some file system modifications. Typically, what you do is just you have an overlay file system where you have a /etc directory, for instance, and all your config files you put in there, and then you have a script that, after debootstrapping, copies everything over your root file system. Pretty easy. There are also some slightly more complex things in there, like generating SSH keys, but nothing major. And then once you have the file system, you have to create a target image file, for instance. If it's going to an SD card and you want to have an image of the whole SD card, you make an empty 1 GB file. You loop back mount. You partition that file. You can just use parted or whatever tool to add a partition table to it. You loop back mount one of the partitions, and you do an mkfs on it, and then you copy everything into it. So that's the easy way, but you see it's already quite a few steps. Now, if you're not going to a PC, but you're going to a foreign architecture, it becomes slightly more complex. Fortunately, there are many tools that help with it, and I'll come to that. First of all, your pdbuild is not going to work out of the box because you need a cross-build environment. So you need an environment where the libraries, the required libraries of the targets are installed, but where the compiler is a cross-compiler. So you have to debootstrap a cross-build root directory, and then, sorry, that's I'm mistaken with something else. Sorry, no. The easiest way is actually to not do any cross-compilation, but just make a root file system of your target system directly, and then use QEMU, or however you pronounce that, to emulate the target processor and run a chroot into your target file system directly. I say QEMU boot here, but it's of course QEMU chroot. And then in the QEMU environment, there you install the build required packages, you build custom packages, and then you have your custom package. So then you can debootstrap your target root directory, and then use QEMU boot to install QEMU chroot, to install the required packages with the cross-compiled apt-get. And the last steps are the same. So you make your file system modifications and create a target image file. Now all this QEMUing, there is a tool that helps for that. That is called Scratchbox2. I haven't used it myself. I just, when doing research for this presentation, I found out about it. The last time I did this process is 3 years ago, and then it didn't exist yet. So, yeah. Actually, there is a microphone for here in front, the second row.
I was just going to say that you can do it with emulation like that, yes, but you can also do it with the cross-building, and a lot of the cross-building tools are increasing in their easy use.
I was going to come to that.
Right, you're going to come to that.
Yeah. Okay. I maybe should have put that now, but it's a bit later in my slides. Now, there are a couple of problems with using Debian for embedded, and I'll talk about some solutions for these problems. So first is cross-compilation. Having this QEMU in the loop is not really good for performance because, well, of course it's emulation, so it's going to slow you down quite a lot. And you can imagine compiling a kernel in an emulated environment is going to take a bit of time. So cross-compilation is one first problem. Second is that the really exotic architectures are not supported by Debian. And then I'm thinking about Blackfin, which doesn't even have an MMU, and Extensa, which also doesn't. Well, I think there the MMU is optional. But fortunately, you don't see these architectures very often. An important problem is that it results in a large system. So a minimal Debian install is typically more than 100 megabytes. So yeah, you really have to do something about that. And then it's not reproducible. That is, to make it reproducible, you have to do some effort yourself. And it's also not very controllable. I'll explain that in more detail. So cross-compilation issues. Well, as we said, you can fake the native build with QEMU, but fortunately there's a project called Emdebian, which started something like 5 years ago, or more, it's longer ago, but it started to pick up 5 years ago. At this point, the cross-compilation toolchain is easy to use as just a compiler, but to use it to build packages is not entirely trivial yet, because you need to have your dependencies in a place where there is accessible for the cross-compilation tool. And for now, the Emdebian people have said it's too difficult now, but in Wheezy, the release which is due more or less now, I think, there will be full multi-architecture support, so you can have all the libraries can be side by side for multiple architectures, and that makes it very easy to support this cross-compilation environment in a typical Debian way. So it's almost as if it's native compilation. So this development has basically been put on hold until now when Wheezy is released. And in Wheezy, it's going to be much simpler to do cross-compilation. But I haven't seen it yet, so I can't really give much details about that. And then there is always an issue that the upstreams typically don't care about cross-compilation. And so you need to add patches to support cross-compilation in the first place. So the upstreams will typically hard-code paths to /user_lib, for instance, or user includes. So you're pointing to the wrong development files. Or they will build something which they execute to find something about the environment. And then, of course, if you build that with the cross-compiler, you can't actually execute it. So you need patches to solve those things. Or sometimes there are other workarounds, like running something in QEMU. And the Emdebian people are basically very busy doing that kind of things. Okay, then the second issue was that a minimal Debian system is already pretty large, and then you don't have any GUI, for instance. You don't have, well, the reason that you use a distro is because it has a lot of packages, and you don't have anything yet. Well, just the shell, basically. So how can we make this smaller? First of all, there is a lot of really unneeded stuff, like the documentation, or actually the user share doc directory, which contains the copyright and a README and the changelog. All of that is on your embedded system not relevant because it's not accessible. The user typically doesn't have an SSH into the system. So there's no use putting that even there. And then there are some packages that Debian considers essential, but which are quite large. The typical example is Perl, which is used by apt and even dpackage, I think. And so, yeah, that adds a lot to your system. And Perl, in fact, it can be made smaller, but when you say Perl, it's already a big Perl that is installed. So it's possible to make a smaller Perl, but the default Debian Perl is a full-featured Perl. Sometimes you also want to split the packages more aggressively. Some packages are split very well. For instance, Qt is split into the Qt core and then all the different modules. But for some packages, this is not done. And so there could be more splitting. And then the dpackage support files, if you're not going to support upgrading using apt-get on your embedded system, then it doesn't make sense to have those support files once you're deploying. So you can basically remove varlib dpackage. That's it. So with all this is another thing that Emdebian does. It makes it possible to remove all these unnecessary things. With all this, you can get down to 20 megabytes, which is good. Could be smaller, but it's already nice. But note that this is not giving you any anything extra yet. And I'm not sure if Emdebian, for instance, has already started looking at Xorg, which is quite large, which can really be easily made smaller. So here's an overview of what Emdebian is. So the idea is to make maximal use of the 20,000 packages that are available in Debian. And the easiest way to do that is what Emdebian calls grip, so getting a grip on Debian. There is mainly doing this first part, removing the stuff that you don't need, the documentation, translations, and also a bit of the splitting the packages. Basically, it just changes the control file of a package to or the Debian rules file of a package to remove the documentation. That's the essential thing. And of course, the Debian people are smart, so they have immediately made a tool that does that automatically. So you just have to run this tool on a certain package, and it will make it a grip package. So it will remove documentation and make it already a lot smaller. This grip is fully binary compatible with Debian, so you can make a mix of Debian packages and grip packages. And the grip packages are a bit smaller. And you can easily add more packages to grip. I'm going back to baked later. The second one is the path using cross-compilation. So where you have the cross-compilation toolchains, which I mentioned before, and where you have binary packages, but I don't know what the renamed means actually, which are really minimized, so which basically don't depend on Perl anymore. That's the important thing. And that way you can make a minimal install, a really minimal install of the 20 megabytes, which I mentioned. But because it doesn't have the normal support files, you can't simply take a Debian package and install it in a crush build. And so you see there's 20 packages here. That's because this cross-compilation is too difficult without a multi-arc, so they basically stopped it. And with Wheezy, I guess this will pick up pretty quickly. Because it's also not very difficult anymore to do this cross-compilation. And so the idea of Crush is that you use some of the Crush binary packages, and then you just compile your own, the extras that you need, using those the tools from grip to strip off the unnecessary parts. And then finally, there is baked. The idea there is that you take some packages from grip or Crush, and then remove all the unnecessary things like the support file, varlibd package. It's something which is no longer installable. You can't do an apt-get in it, but it's a working system, and that's in the end what you want. This stuff, multistrap is also pretty important. It's a tool that enables cross-installation. It's a cross-debootstrap, basically. So it helps you with doing debootstrap of a foreign architecture. And then reprepro is one of the tools that you need to make it reproducible. I'll come back to that. Yeah, so I've already mentioned this. So what does Emdebian do? Make it smaller and make it cross-building. And then the tools are this xcontrol file. The smaller packages, the control file is renamed to xcontrol to make it clear that it's a modified package. And then there are tools to automatically create those files. And another important feature is that it separates translations so that you can still have translations of a package, but you don't need all translations when you install it. For instance, when you install core utils, you will get translations of core utils into something like 50 languages, while typically on your embedded system, you need none, or maybe one is enough. And then there are these specific required and essential packages to make Crush possible. The cross-compilation tool chains. And basically all of this stuff is just in the Debian repository. So everything that Debian develops, it maybe starts in a separate repository, but it migrates into the core Debian. So you can just, on your Debian system, do an apt-get install, depackage cross, and so on. Then these tools supporting cross-installation, these are being reworked for the multi-arc based approach. So reproducibility. One important problem with reproducibility is that you install something now, and to install that, you get things from Debian.org, but then a year down the line, there have been upgrades, and so it's no longer on Debian.org. There's just a new version on Debian.org. There's a question there? The microphone, yeah.
Are you using Debian testing or unstable?
What do you mean with me?
Package removed from Debian, that doesn't happen in a stable release.
The package is not removed, the version is removed. And it's not really gone, it's removed from the main archive.
It depends on your timescales. Even stable will eventually go to old stable, and then old stable will disappear once the next stable is coming through. So
but anyway, there is a solution. There is snapshot.debian.org, where basically everything is kept, what was ever on Debian. So you can use that to, you just put your first build date, you put that build date in the URL, and then later on, when you rebuild, you will have exactly the same packages. And the main advantage of this is that you can also, from the snapshot, have access to the source packages. The alternative, if you don't trust Debian to maintain the snapshot, the alternative is to create a local cache. Sorry. So basically, when you download, you cache the package that you download, and then afterwards, for your rebuilds, you will use your local cache instead. And that's where reprepro comes in to build your local cache. The advantage of this one is that you can nicely combine your local cache with your own packages in a single repository, and that you only need to have one source in your sources list. Very important is that you have a top-level build script that automatically does everything, so that when late a year or 5 down the line you need to rebuild it, that you can just rebuild it without trying to find out how was this done in the first place. This is actually something where Debian could use a little more support. So there are some tools like multistrap that make it a bit easier, but it's still, you have to find out a lot of things by yourself. But I'm sure Emdebian will evolve in that way. Controllability is another issue. And that's where I personally don't see the evolution going so well. The problem is that since you're not doing the packaging, someone else has done the packaging, they have made some choices about how the packages are made. So this includes the compilation options that are used. It includes the dependencies which are used. For instance, is it built with OpenSSL support or not? There are some choices made during packaging. In particular, you have some global architecture options. Is it do you compile for ARMv6 or ARMv5? I guess I actually should have checked. I guess Debian will normally compile for ARMv5 so that it will run on a v5 and on a v6. Yeah. And on v7, yeah, okay. But then it's really a different different architecture, so it's not doesn't work out of the box. But there is a solution for that, of course. That's building from source, which is fairly easy. You just do a dpackage build package, and with pdbuild you make sure that it's reproducible by downloading all the dependencies. Now, if you just rebuild from source, of course, nothing has happened. You also have to modify Debian rules or maybe even change the source itself and add some patches to it. Which brings me to the second point. So one thing you often also want to do is to integrate new features. For instance, in one of my projects, I'm using a zip package, which has video support, but not for the particular architecture that we're targeting. So we've added it ourselves. But then, of course, that's not in the Debian package, so we have to rebuild the Debian package to have that. So you can build from source. An alternative is also to do a mixed system where you get the package from unstable or experimental, which typically has a more recent version. But the main thing is that the system integration choice has been made by Debian. So how the init works, how the the boot process is the package dependency. So typically runtime dependencies or packages are also added to the packages dependencies. But sometimes you don't need that particular runtime dependency because you're not using it. And so those choices are made by Debian, and it's that's a bit more difficult to work around. Again, you can make your own packages, but here it becomes difficult to do that because there is a variety of ways in which this is done. And understanding the init scripts, for instance, is not so trivial. So for developers who really want to develop their application and they don't want to be system administrators, this is a kind of big hurdle to understand how the boot process works and how the packaging system works. Making a Debian package, that's fairly easy. That's not much of a problem. But this system integration, or being a system administrator, basically, that's making things more difficult for the embedded developers. So Debian has some disadvantages, though they are not too big. It's still very usable for an embedded system, and it will still save you a lot of time compared to starting from scratch. So the initial default deployment, that's definitely, you just take a root-if-s, boot it, and then start apt-getting the stuff that you need. Although actually there also, it takes a bit of finding where to find just a root-if-s without anything else. It's not one of the normal Debian install options. The fast building, well, actually that's another thing where Debian doesn't score very well, because if you use pdbuild, then it will make a new root every time and install the build dependencies every time, which is very good for reproducibility, but it does mean that it takes a long time, because for every source package that you compile, this is done. You can then make workarounds like reusing your root, but then you lose some of the predictability. Although actually, if you always do that in the same way, it's of course still reproducible and predictable. But so the building is not very fast, and especially if you have to use QEMU, then it's pretty slow. It's fairly easy to change the configuration, although, so definitely when it comes down to choosing packages, it's very easy. When you have to modify packages, it's a bit more work, but it's still doable. Easy to share with colleagues if you have that build script. It's reproducible. You can make an image, and you can easily add new custom packages. Now let's look at an alternative, buildroot. Buildroot was created basically with the idea we really want to build our embedded system from scratch. So let's do that, but let's make it easy to build from scratch. And what is it? It's a configuration environment using kconfig from the kernel, and then a build system based on makefiles, which will build your Linux system from scratch. So it will download, patch, build, and install the toolchain itself. It will install the packages that you have selected in this configuration environment. It will automatically add dependencies, but only the really required dependencies. If there are optional dependencies, then usually there's a configuration option for them. It also supports the different bootloaders, the kernel, all of that in one configuration environment. And also some host tools, which are typical for embedded, like OpenOCD, which is a JTAG debugging environment, and a few others. And I'll pull this down a bit. Below the screen here, it says that it also creates the root file system in several formats. There is an X2, but the X2 is actually not used very often in embedded systems. Maybe during development when you boot from SD card, but in the end it's going to flash, and there you put typically a JFS2 or a UBFS. And so buildroot supports all of these in the same way. So the workflow is pretty simple. You download buildroot, which is these makefiles, kconfigs, and patches. Then you do a make xconfig, do some selection, do make, and then wait for, if you do a minimal install with downloading a pre-built toolchain, you can build it, including the kernel, in about an hour on my laptop. So the building consists of downloading those packages, compiling them, and installing them into a target's file system. And you end up with a root file system, which is suitable for flashing directly to your flash, a kernel, a bootloader image, all the different components that you need. So some examples. I'm not going to do a live demo now because the time is too short for that. But so this is a screenshot of the xconfig. For people who have done kernel builds, it will look familiar. You select your target architecture. You can also select the target architecture variant. So within ARM, you have many different ARM processors, and by selecting the one that you have, it will generate optimized code for that architecture. What we still want to do, but what isn't there yet, is that it also will automatically select the floating point support. For instance, on Cortex A8, you have a Neon coprocessor, and ideally you should make use of that. And then the toolchain, you can build a toolchain yourself using either a bit deprecated internal toolchain build system or CrossTool-ng, which is a generic project to make cross-compilation toolchains, which is actually, I think, used by Linaro to build their external toolchains. You select which toolchain you want. I don't know why, but normally there should be also Linaro toolchains in here. It's because it's not a Cortex, yeah. And then you can download and install that toolchain. Changing the configuration is easy. For instance, for Qt, you can select the Qt package, of course. But then within the Qt package, you can make all kinds of configuration options, like do you want a shared library or a static library? A static library is interesting because it can make your application loading faster because you don't have to do the name resolution. You can even make it smaller if there is not much of Qt that you use, then only the necessary parts will be in your executable. For instance, you can select which pixel depths you want to support. If you have just a 16-bit screen, then you don't need to support all the other pixel depths, which reduces the size a bit. And then for all the Qt modules, you can select them or deselect them. Also, the compatibility with Qt3, which is interesting to remove because that takes away some codes. So these are basically build time options, where if you would use a distro, you would have to rebuild from source to be able to access these options. And also, the Linux is completely integrated. So if you want to change your Linux configuration, you just do make Linux xconfig, and you get your Linux configurator screen. You can then save the resulting configuration file, and when you rebuild it, it will use the saved configuration file. So even if you remove everything and you rebuild with the same buildroot configuration file and Linux configuration file, you get exactly the same build. So that's what makes it easy to share with colleagues. You just have to share your configuration files, which is the buildroot configuration file, and then for a few other packages also a configuration file. And you just give that to somebody else, and they can run directly and make exactly the same builds. What I said, you can also make sure that you have all the source packages collected. For instance, if you want to do offline builds, if you're mobile and you have a bit of time on the internet, you do a make source that will make sure that all the packages are downloaded, and then you can build later. Most interesting is the make legal info. So in Debian, the legal support, knowing which copyrights there are, is done by having this user share doc, where for every package there is a copyright file. But of course, in Emdebian, we're going to remove that, so you don't have it anymore. You still have it if you take the same configuration from a normal Debian, but it's a bit makes it more difficult for your legal department. With make legal info, what that will do is it will question.
Just very quickly, we don't actually. The one thing we keep in user share doc is the copyright file, but we compress it.
Ah, okay, I didn't know that. So what make legal info does is it for all the packages it takes the source, because you usually need that usually for the GPL packages you need that. It also takes the copyright files. For that, we are still in a process of defining where the copyright file is, because it's not always called copyright. And so of the 800 packages we have in buildroot, I think there are about 300 or 400 which have the legal info support. And it makes a summary of this in a CSV file, which is something you can give to a lawyer that doesn't know anything. And that CSV file will say for every package what the license is, and where the source is and where the copyright file is. And so that lawyer can see, GPL, 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 that's okay, or not okay, because sometimes they're difficult. And then there are some exotic things like I can't think of any, but there are packages which have non-standard licenses, which have to be looked at by legal department to know what's going on there. Hacking a package is also easy. So if you want to make a different, build a package from a different source or different version than what is in buildroot itself, then you just have some file which is configured here, the package override file, and you add a line to that like this. Linux override source there is, and then some path, and then it will take the sources from there instead of from the normal download source. That makes it easy to hack things, and then you can also create patches and add these to buildroot to make it reproducible. And to create a package, you need a file like this. This part is actually, if you want to make it really simple, I'll come back to that. Basically, you have to say where the package comes from. In this case, I'm going to just compile from a local directory, so I give a path, which dependencies it has. Well, these are actually only the build dependencies. Then how to build it. If you use make, then it's usually something like that. And then how to install it. You can make an install target in your make file, but you can also just call the install from the buildroot make file, and you don't need anything more. Well, except the thing that fell off here. There is a line which tells buildroot what to do with these definitions. So this is actually makefile syntax, but you don't really see that it's a makefile because there's not much typical make things that are used in there. This top one, this is actually a kconfig symbol. All the kconfig symbols used by buildroot start with BR2, but you can actually define them just as well in a makefile, and it will then be used by make. So if you want to select this package without having to bother with selecting it in kconfig, if you want to force select it, you can just add this line to your .mk file. Another important thing is that all this is documented pretty well in a single manual of something like 50 pages, which basically says everything there is to know about buildroot. So You don't have to look in different places on the internet to find how to tune your system, for instance. And then cross-compiling some source without making it a buildroot package is also easy. So you have your buildroot directory, and then this path output host user, and then the cross-compilation tuple like ARM buildroot Linux, GCC for the compiler, or R for the archiver. And if you use that path, then it will use your cross-build environment to find libraries and include. Okay. Is this on? Yeah. So you have your sysrooted environment that is used directly by if you use this compiler. So you typically don't need to use any extra -i options or anything. And then for packages which use package config, you just point not to the user bin package config, but to the buildroot package config. And that will also make sure that all the right options are given and the right paths are given. If you want to share this cross-build environment with colleagues, there is a configuration option BR2 host there, which you can set to, for instance, /opt/my-path. And when you build it, all the cross-compilation stuff will be in that directory. And then if another person points to the same directory, they can directly use the same buildroot environments. Yeah, so documentation I mentioned already. There's also a pretty active mailing list, about 40 mails a day, of which most are patches. We have maybe 1 or 2 questions per week only. The rate of development is not fast, but not slow either, so about 20 new packages per month. And there's a fixed release schedule, release every 3 months, and shortly after Fosdem, we have buildroot developer days on Monday and Tuesday, and then shortly after that there will be an RC1 probably. I forgot to mention that the maintainer is Peter Korsgaard, who happens to live in Belgium. We also have automatic tests, about 100 builds are done per day, to see if everything still builds in all possible exotic combinations. Now I have to admit about half of these builds fail, because cross-compilation is difficult. So sometimes there is some cross-compilation patch needed. Sometimes the package just doesn't work on some architectures. For instance, there are many packages that require an MMU because they use fork instead of vfork, and fork is only supported if you have an MMU, and then the build will fail. So these automatic tests help us to discover that, and hopefully with some time we can reduce this number of failed builds to 0. So let's take an overview of what distro options we have for embedded systems. What I discussed now are basically 2 extremes on a scale. So we have the buildroot, which is a build from scratch system, versus a Debian, which is really a distro, but with flexibility to add your own stuff. There's one thing, PTX-dist, which had a talk at exactly the same time in the embedded dev room, which is basically nearly the same as buildroot. Just it started at the same time, and there are parallel projects like Debian and Fedora, for instance. Then there are OpenWRT and OpenEmbedded are a bit more like distro because they support runtime package management. Yocto, it's an OpenEmbedded derivative, which is also a bit more distro-like. And then Gen2 is a bit special because it's a distro, but it also builds from source. I unfortunately have never used Gentoo myself, because it would be very interesting to see how it compares to buildroot. Now buildroot has some limitations as well. There is no live CD, so you always have to build, which is, for me, it's actually an advantage, because then I know what's happening and it's not doing something under the hood. The config menu is a bit large. You can be a bit overwhelmed by all of the options. There are only 1,000 packages versus 20,000 in Debian. Now, most interesting packages are in there, like Xorg is in there, so you can have a GUI. There are many different window managers even in there, but KDE, for instance, isn't in there, because we usually don't need KDE on an embedded system, and especially then it doesn't have to be small, because it's so large that, yeah, source packages. There are 18,773 source packages in Debian. Yeah. Yeah. The fact that it has no binary packages could mean that the build takes longer, but in fact, with this the bootstrap and so on, that's actually fairly slow. So in practice, sometimes buildroot builds faster than Debian builds.
The bootstrap, if you have local cache of Debian packages and you do it in RAM, can make a good image in something like 1 minute.
Last time I did it was it always took an hour, so but it's years ago, I have to admit. No, from a local network cache. But anyway, my time is almost up, so. One of the most important disadvantages is that since it has no package management, if you want to remove a package, you have to do a clean rebuild, which makes removing a package a bit slow. Now to the most important thing of the talk is how to choose between Debian and buildroot. Basically, Debian is interesting if there is a live CD. Then you can go quickly. So basically, on PC, it's interesting. It's also useful to start with Debian, not even Emdebian, but just Debian, to see what packages there are and what you need, and then go to something like buildroot or one of the alternatives to really lock down and make it a small system. Emdebian makes good progress, but there's still some way to go. Now with Wheezy, it's going to hopefully be better, but it still has some way to go. And in my personal experience, but of course I'm a buildroot contributor, so I'm a bit biased. Buildroot is smaller and is actually easier to use once you're used to it. Making an image for a new board is really peanuts, and then adding packages is also very easy. So for me, there's not much need to use Debian for embedded. But for newcomers, the live CD is interesting. But so using a distro, it's fairly easy to, within days, get an initial working system, basic system, for your embedded system, which makes your development a lot faster. Are there any questions? If there is time left.
Can you give some examples for some hardware, the size of it of a buildroot build?
Excuse me. There is someone who had a PC with 1 megabyte of I don't know what kind of storage, but 1 megabyte of storage, and it could fit a buildroot built in there. So 1 megabyte is a minimum.
So the default build that you do, it is just a C library and BusyBox, and it's a system that boots, gives you a shell and all the kind of standard Unix utilities, and I think it weighs less than 2 megs, uncompressed. with network support and things like that. Without the kernel, of course, just the root file system itself. So you add something like about 2 megs for the kernel, so 4 megs total. You have the minimal system that boots and does something.
Just as an aside, in the embedded development that I actually do for my employer, we use both. We use buildroot to be the rescue environment that goes into some no flash. It's a minimal, I think it's a 3 megabyte image that we put into there. And then we chain into Emdebian for the actual running system, because that system is one of these systems where we need to have a package manager. We need to, for this particular product range, we need to be able to update and remove packages cleanly, add things, take things out. So the two can work together quite nicely, depending on exactly what you're trying to do and which bit you need the support in.
Maybe I can add to that indeed buildroot is used in not only for embedded systems as such, but also to make, for instance, an init ramfs to boot into something else, or in many there is somebody who wants to have a desktop environment using buildroot and he's porting Firefox. But time is up, so I have to stop here.